In this lecture, I will try to solve the connectivity issue between the loopback number 11 on router 1 and the loopback number 33 on router 3. So if I go now to router 1 and try to ping the 33 IP address using the 11 loopback as a source, we see that the ping is not successful. If I try to display the BGP table on router 1, we see that the BGP table is empty. If I try to check the neighborship with router 2, we see that the neighborship is idle, and here we see that router 1 is using a wrong AS number for router 2, so this could be the issue. If I try to use the show run section BGP command, we see that router 1 is using a wrong autonomous system number to establish the neighborship with router 2. So let us correct that. So router BGP 12, and then neighbor should be with the correct AS number, which is 12. We see that the neighborship is up now. Let us verify on router 1 using the command show IP BGP to see if the network is there. We see that router 1 does not have the network, so let us check on router 2. So IP BGP, we see that it also does not have the network. Let us check the neighborship with router 3. We see that the neighborship is up, but we do not have any prefixes received. Let us check if router 3 is actually advertising the network. So show IP BGP neighbor 2.2.2.2 advertised routes. We see that router 3 is actually advertising the route, but why router 2 is not having the route? Let us check using the command do or debug IP BGP updates, and then clear IP BGP 3.3.3.3 in. We see that the route is denied due to AS length over maximum limit 3. So we have maximum AS number set as 3, and we are receiving an AS path which contains 4 autonomous system numbers. So it is a long AS path that we cannot accept. So we check on router 2 using the command show run section BGP. We see that we have the BGP max AS limit set to 3, so we do not accept AS path with 4 AS number or AS paths. So let us check on router 3 why is that occur. So on router 3 we issue the command show IP BGP neighbor 2.2.2.2 include map, because this can be as a reason for a route map configured on router 3 that is adding additional AS path numbers. So we see that we have a route outgoing or outbound route map with the name of router 2. let us check this route map. We see that router 3 is preventing additional AS numbers to the AS path, which causes the problem. So we can solve this issue by just remove this prevent statement, but as we know that we are not allowed to remove route maps or modify them on router 3, so we can use another solution, which is removing the max AS limit command on router 2 or modify the value. And as we know that it is preferred to modify features and not removing them, so I will set the max AS limit to be 4, and then I will clear the IP BGP with router 3 in the inbound direction. Now let us check for the route. So show IP BGP. We see that we have the route now. Let us check on router 1. We see that router 1 has the route now. Let us check if we can ping. So do ping 33 IP from the loopback 11. We see that the ping is still not successful. Let us check if router 3 has the 11 route. We see that router 3 does not have the 11 route. Let us check if router 2 advertise it. So do show IP BGP neighbor 3.3.3.3 advertise routes. We see that router 2 does not advertise the route, and this could be because of a route map on router 2 that prevents the advertisement, or because router 2 does not have the route from the beginning. Let us check if router 2 have the route. So do show or advertise the route. So do show IP BGP. We see that router 2 does not have the route in the BGP table, so it does not try to advertise it from the beginning. So this could be because the network command is not configured on router 2, or it is a wrong network command, or even because router 2 does not have the route in its routing table. So let us check show IP route 11.11.11.11. We see that it has the route in its routing table, so it receives the route from router 1, and the route is with a /24 mask. Let us check on the BGP configuration of router 2. We see that router 2 is using the network command on the BGP configuration, but we see that it uses a mask of /32, while the network is with a /24 in the routing table. And for BGP in order for BGP to advertise networks with the network command, it should be with the same value of the network and with the same value for the mask, which is not the case here. So we can go to the routing or router BGP of router 2 and correct this network statement. So I will remove this one and then use the correct mask. Let us verify now on router 3. We see that the network is here on router 3, and we use the network command on router 2 because we are not allowed to configure the network command on router 1. So router 1 should advertise this using OSPF, and then router 2 will inject it into the BGP using the network command. Let us now on router 1 check if we can ping. We see that the ping is now successful.